All right, so 2, 4 is complex numbers. If you remember complex numbers, these are your I values, okay? So moving forward, you're going to be really careful when you're looking at instructions on questions, because if things say like identify the real roots, then you don't include I's. If it just says to identify the answers or simplify or find the roots, then you do include I's, okay? So now you've got 2 different types of numbers going on. The imaginary unit, which is I, is defined as the square root of -1. So the square root of -1 is I, which means I squared is -1. So from here on out, when you see the square root of -1, you're going to replace it with an I. If you see I squared, you're going to replace it with a -1. Complex and imaginary numbers have 2 parts. The real part, which is the part that doesn't have an I, and the imaginary part, which is the part that does have an I. They are labeled as A and B. So A is the part that is the real part that doesn't have an I. And then the B is the imaginary part that does have the I attached to it. If there's no A, which means it will look something like 2I or -3I, if there's no A, then it's called a pure imaginary number. So when you're identifying the parts of your complex numbers, the A is, again, that's by itself. The B is the number that's attached to the I but does not include the I. So if you had something like -4 plus 6I and it wants you to identify the A and the B, the A is the -4, the B is just 6. So again, you don't take the I with it. The B is what's attached to the I, but the I is not there. This is what's called standard form. So in standard form, the I is last. Okay, so you would write your real part, plus or minus, whatever it is, the B, and then the I comes last. So if you've got a square root, usually it's bumped to the end of the square root. When we get into fractions and stuff like that, it's going to be bumped to the end of it. The I is usually the last thing that's written. Okay, so first example is just say to express as a multiple of I. The very first thing you do when you see a negative underneath the square root, you want to take it out. So by taking it out, I'm making it I square root 16, then simplify it. So square root 16 is what? 4, and the I comes last, so that's just 4I. If I had 7I squared, this is the same thing as saying 7 squared and then I squared. 7 squared is 49. I squared is what? -1, so this is -49. Standardized tests love to do things like I to the 36, okay? They love things that, like, if you go the long way, it kills your time, but there's an easier way to do it, right?
If it's even, it's positive. If it's odd, it's negative.
If it's right, and then you've got to figure out if it goes in evenly, is there an I or is there not an I? So if the number, the exponent, is even, right? Then that means there's going to be an even number of I's, which means there's going to be an I. Which means the I is going to cancel out. But then you have to figure out, is it supposed to be a positive one or is it a negative one, right? So that becomes what happens when you divide the exponent by 2. So 36 divided by 2 is I squared would be raised to the 18. Does that make sense?
Yeah.
Okay, so that means there's 18 I squares, which means there's 18 what's?
-1.
There's 18 negative ones. If there's an even number of negatives, what happens? It goes back positive, so this is just +1. If my number was like 38, this is I squared raised to the 19. Now there's 19 negative ones, which tells you what? An odd number of negatives is negative. This is -1, okay? So that's the first scenario, is that the exponent is even, which means your answer is either going to be a +1 or a -1. The second scenario is that your answer is odd. So let's say it's 27. This is the same thing as saying I squared raised to the, what's 27 divided by 2? 13 with 1 remainder, right? So this is saying I have 13 pairs of I squareds, right? But I also have an I. So if your exponent's odd, I is always going to be in your answer. The question is it a positive I or a negative I? And that goes back to what we just did. If it's I squared raised to the 13th, that means it's a negative 1 times I is negative I.
So you can't go off your original exponent. You have to break it up and then figure it out.
Correct. Because
Because
if it's even, what you do know is if your original is even, so if it's even,
Like 38.
then there's no I in your answer. If it's odd, then there is an I in your answer. But then you have to divide that by 2. And if that answer is even, then it's a positive I. If that answer is odd, then it's a negative I. Does that make sense?
Yeah.
So if your exponent divided by 2 is even, then the answer is positive. If it's odd, then it's negative. But if your original is even, there's no I. If your original is even is odd, then there is an I.
So for the last one, you pick like to kind of give like an idea. It's just that you kind of work it as if it's an odd exponent, and then at the end, since you know it's a remainder because you can't divide it by 2, that's when you realize, oh, there's also an I at the end.
Sure. So like if I had I, let's say I had I to the 29th, right? This is, you can write this as I to the 28th times I, if that's easier. And then I to the 28th would be I squared to the 14th. That means there's an even number of negative numbers, of negative ones, which makes that positive. And then a positive 1 times I. Does that make sense?
Yes.
Okay. So sometimes it's easier to take it off, make it the even, and then make sure you add it back on at the end. So again, initial even, it's your I's going to cancel out. Initial odd, your I's going to be at the end. And then you would go to the divide by 2 and see what it is. Okay. So when you're adding and subtracting complex numbers, it's just like when you're adding and subtracting things that have x. You're going to combine your like terms, and you're going to treat I as though it's a variable. The only difference is that when you are working into multiplication, which we're going to look at next, your I squareds have to get taken over by negative 1s. That's it. You can't leave an I squared in your answer, or an I to the greater power than squared. So this says perform the indicated operation, which is what the directions will usually say, or it will say simplify. You've got to be able to look at it and know that it's addition, subtraction, whatever it's supposed to be. So the first one is 7 plus 4i minus 9 minus 5i. So this negative is just going to get distributed to both. So 7 plus 4i minus 9 plus 5i. And then combine your like terms, negative 2 plus 9i. Remember, standard form, you are always going to bump the I to the end, so you always want it to be the last thing that you're writing.
Are we ever going to get a quiz question like that?
Probably not. Maybe. I'm in a really good mood.
Please.
Maybe. What happens with the second one, though, is even if I try to give you an even easy question, people like forget that this is here and then FOIL that out. Don't do that. Okay, this is addition, which means I just have to combine my like terms. 25 minus 4i. And yet people will still mess that up. The smarter you are, the dumber your mistakes are sometimes. Because you try to do stuff in your head, because you think you're too smart to write things down, or too lazy. Okay, multiplication. Again, if it's two binomials, you'll FOIL it out, but this time you can't leave x squared like you normally would, or you can't leave it squared like you normally would with x. You would have to replace your I squared with negative 1. All right, so those look like this. So A, 3 times 6 is 18, 3 times negative 2, negative 6i, negative 30i, and positive 10i squared. So I'm going to combine my like terms. I'm going to change that I squared into negative 1, which means this is negative 10, 8 minus 36i. Easy stuff, right?
Like your factor. Got it.
Mm-hmm. Okay, so B is not 2 squared and negative 3i squared, right? You got to expand it and FOIL it out. 2 times 2 is 4, minus 6i plus 9i squared. 4 minus 12i, this becomes negative 1 minus 9, and I get negative 5 minus 12i. Still good? Yep. Yeah, good job. Okay, the conjugate of a complex number is the same exact expression with the opposite sign in between. So we don't change the sign on the A, you only change the sign on what's in between, which is the B. Okay, so if I had 2 plus 3i, then the conjugate is 2 minus 3i. If I had 3 minus 5i, then the conjugate is 3 plus 5i. And what happens when you multiply a complex number by its conjugate is you lose the I and you get the real number. So if I had A plus BI and A minus BI, I can go through the whole process of FOILing it out, and I will always end up with A squared plus B squared, which is a shortcut.
That's kind of like what we did with the roots, like when it gave you the factor of 2 plus square root of 3, 2 minus square root of 3, kind of thing.
Yes, except that was minus, right? So if you have difference of two squares, if you have 2 plus 3x, 2 minus 3x, right? Or reverse, 3x plus 2 and 3x minus, whatever it is. We did the first one squared minus the second one squared. Mm-hmm. Right?
Yeah.
The difference with complex is this one's always going to have an I on it, which means it's always going to change the sign inside to plus. So the shortcut this time is A squared plus B squared. Exactly. So if I had 3 plus or 2 plus 3i and 2 minus 3i, then it's 2 squared plus 3 squared. Now be careful because B is just what's in front of the I, right? Mm-hmm. So I don't account for the I. The plus is accounting for that I. So this would be 4 plus 9, which is 13. So the shortcut with with complex numbers only is A squared plus B squared.
You just ignore the signs and get the numbers in the square.
Correct. And then make sure you add them together at the end. Yep. Okay, so it says write the complex conjugate of the complex number, then multiply the number by its conjugate. So if 7 minus 10i, what's the conjugate? 7 plus 10i, what's the shortcut? 7 squared plus 10 squared. 49 plus 100. 149. You can go a long way and FOIL it out. You'll get the same answer. Okay, B is not yet complex, but what would that be if it was complex? I root 5 or root 5i, same thing, right? What's the A there?
The root 5.
Nothing. The A is 0, right? And the B is root 5, right? So the complex conjugate is negative root 5i. That's the conjugate. And if I use the shortcut here, it's like saying 0 squared plus root 5 squared, which is just 5. So keep in mind that your A would be 0 if there's no complex conjugate, if there's no real part, right? Questions on that part? All right, so this is why we're going to use it. Okay, when you have a complex number in a fraction, if it's in the denominator, it's the same thing as having the square root in the denominator, and we can't leave it there, right? It's irrational. So we're going to eliminate a complex number in a denominator by rationalizing, by multiplying the numerator and the denominator by the conjugate.
You have a slide in between these two.
Do I? Did I skip it? This kind of goes back to when we used to rationalize fractions. So if I had 2 over root 3, I would multiply both the top and the bottom by root 3 to get rid of it, right? You can't leave the root 3 in the bottom. So the same thing is going to happen if it said 2 over 3 plus 4i. You're going to multiply both the top and the bottom by the conjugate because, again, you can't leave a square root in the bottom, and the I is a representation of a square root. So you're going to multiply both the top and the bottom by the conjugate. The top you're going to FOIL out or distribute, whatever you need to do to simplify. And the bottom you can use your shortcut on. All right, so example 5 specifically says divide, but I will tell you that after this point it's just going to say perform the indicated operation and you need to know what to do. So 3 over 5i would mean my complex conjugate is what? Negative 5i. So I'm going to multiply both the top and the bottom by negative 5i. And the top becomes negative 15i. And the bottom, I can either a squared plus b squared or literally multiply that out. Whichever is faster for you, do it. This would be negative 25i squared, which goes back to being positive 25. Or 0 squared plus 5 squared, which is also 25. Yep, always. So if you're writing it like on a quiz or test or whatever, and it's open-ended, you can put the I in the top like that. I don't care. Okay, on a standardized test, and I think on WebAssign, it will keep it separate like that. So we'll put the I at the end. They're both right.
But then put the I at the end, doesn't that make it say it could go in the numerator and the denominator?
Nope, because that would be like I over 1 still, which still, yeah. All right, so numerator should have been negative 19 plus 93i, and then denominator 106. What you want to do is make sure they can't be reduced, either part of it. So when you split this and you get negative 19 over 106, that can't be reduced, and then you do 93 over 106, that can't be reduced, and the I gets bumped to the end. If either part of those can get simplified, you have to do it. So like if the 93 was even, I would need to simplify that part of my fraction. So just be really, really careful there. What? Be more specific than what. Why? Because you have to check to see if either of the fractions can be simplified.
Okay.
So sometimes one can, but the other one can't. You have to split them.
So we write a different answer. Would you like to separate them?
Yeah, if they can't be simplified, it doesn't really matter. But if they can, you need to simplify them. Questions?
Which one does the I go to then?
The I's at the end, so the I's after the 96 over 106.
Okay.
On the other side, you go together.
I don't know the answer to that. You could try. All right, principal square root of a negative. So we kind of talked about this already. It just says that for any positive real number b, the principal square root of the negative number negative b is defined by I root b. The biggest thing is this. You have to first express the root in terms of I and then simplify. So if I have square root negative 3 and square root negative 3, and I multiply those together first, what happens underneath my square root?
It's positive.
It's positive. This becomes square root of positive 9, which is actually 3. That's wrong. You have to take the I out. You have to take the I out. Then multiply them together, which means it's negative 3. So this is actually the correct thing. The top is not. So as soon as you see a negative under a root, you take it out.
Wait, but technically when you multiply, never mind.
There's no way to catch it if you do it the wrong order. Yeah, there's no way. So you got to be really, really careful, okay? Has to take the negative out. All right, so this one says, perform the indicated operations, write the result in standard form. So the first thing you want to do is take the i's out. So this is I root 54 minus 7i root 24. As they are, I cannot combine them, but I can break them down. So 54 is 2 and 27, 3 and 9, 3 and 3. I can bring 2 3s to the outside. So I get 3 times I, and then the 2 and the 3 get multiplied together. That's root 6.
Wait, what?
So there, when I broke 54 down, right, I got 2 3 3 3. So the 2 3s go to the outside.
Yeah, you just did different.
24, you can break down 2 12, 2 6, 2 3. Again, I have a duplicate number. 2 goes to the outside, but it's going to get multiplied by the 7 that's there. So minus 14i. 2 and 3 stay underneath, gets multiplied times root 6. Now they both have an I and they both have a root 6, so this becomes negative 11 root 6i. The I goes last. Okay, just be really careful. If you put the I in between, like I'm not going to mark it wrong, just make sure the I is not underneath the square root, because that's what happens. Questions on that one?
How do you do your trick?
Huh?
How do you do that trick
Which one?
for the break it down?
Like to break it down, you mean? I just factor it till it's primes. And then if it's a duplicate, it comes to the outside. So for a square root, you need 2 of every number. It goes to the outside, right? And then whatever's on the outside gets multiplied, whatever's underneath gets multiplied. All right, try them. Perform the indicated operations again, write in standard form, which means the I comes last. So the first one, you got to take out that I. It becomes 4 plus root 7i, or 4 plus I root 7, and then 4 plus I root 7. FOIL it out. You get 16. 4i root 7, 4i root 7, and then a positive I squared times the square root of 7 squared, which is 7. So I get 16 plus 8i root 7 minus 7, and then I bump the I to the end. So 9 plus 8 root 7i. Again, be careful. Make sure the I does not go underneath the square root. Raise your hand if you got A right. Okay, good. B, you got to take out the negative, making it the I root 48. Break down the 48, which is 4 root 3. And then split them and simplify it. So it would be negative 2 plus root 3i. There were 2 2's that came to the outside that time. So it would have been 2. You could also do 16 times 3 if you're like better at your square roots. And then you could do square root of 16. That's the same thing. Everybody's good? All right, thing is now your quadratics are going to have negative roots, okay? So we already know this, that even if you've been trying to avoid it, you're going to have to know it. Negative b plus or minus the square root of b squared minus 4ac all over 2a is your quadratic formula. A is 4, b is 12, c is 15. And I get negative 12 plus and minus the square root of b squared minus 4 times a times c all over 2 times a. So I get negative 12 plus and minus the square root of 144. This is 60 times 4 minus 240 over 8. Negative 12 plus and minus the square root of negative 96 over 8. And there's that negative. So the negative comes outside the root as an I. 96 is 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. So now you got to miss the factor of all the primes. This is 1, 2 is going to go to the outside. This is another 2 that's going to go to the outside. And then the 2 times 3 stays underneath. And I get negative 12 plus and minus 4i root 6 all over 8. Split it and bump the I to the end. Yep.
Can you just take out the 4?
Yeah, you could do your square roots however you do your square roots.
Wait, what do you mean plus and minus?
Yep. Burnt. Thank you.
I was like, oh.
Negative 3 halves plus and minus root 6 over 2i.
Do you have to split it up?
Yeah, so the reason I split it is because sometimes you'll be able to reduce one part of that and not the other. And if you can reduce one part of it and not the other, you must. So if for some reason that was like over 6, let's say, like this was over 6, and I got negative 12 over 6 plus and minus 4 over 6, these reduce differently. You have to reduce them as though they were split. So that's the only reason I split it.
But on your graph, that wouldn't actually be a point.
Correct. So if you were graphing these, which we're going to eventually put all that stuff together, these would not be points visible on your graph because these are imaginary. Good question, Sophia. Any questions on complex numbers or what we talked about so far today? Okay. All right. Web assign is open, and I'm going to say this again nicely, and then doc points in your homework. But I need to see the full box of all the questions. 1, 2, 3. I think there's 10 of them. So you got to get all of them. I don't want the first 4 cut off. Okay. We've said it a couple of times, and I'm going to walk you through how to do that if you don't know how to do that. Okay. But I need to see the whole box. Your name in the top right corner. Okay. Before the test, there was like a homework that only had 4, so no big deal, okay? But these have more than 4, which means you're going to need to do it. So when you log into your interface, yours looks a little bit different than mine, so I can't show you exactly what it looks like. But when you log into your interface and you click on home, on the very top, there's little icons up here, and one of the icons looks like a little desktop computer. You need to click on that, and then the little pop-up's going to come up and say, switch to old interface, and you're going to click on that again, and your view will change. And when your view changes, you will see the full thing at the top. I actually nope.
Looks strange.
It's different. It's the old one. So you click on home, and then you click on the little thing on the top right, and it's going to say switch to old interface. You have to click it twice, and then you'll get your list of assignments, and then you'll get the whole thing at the top. Okay. You can switch back and forth if you don't like this view for the rest of the assignment, although I think it actually gives you more of the questions in one view. It might be easier. But again, when you take your answer and you screenshot it, you should also have your name, like up here in the top. You want to make sure you have your name. This is cut off because I didn't want that kid's name in there, but it should be in that top corner, okay?